Alright, and welcome to Linear Inverses Level 2. Now in our very first example it says graph f of x and f inverse of x. So let's go ahead and start out with some function. Let's say, you know what, f of x is equal to negative 2x plus 3. Okay, now let's see, what would this look like just to graph this as our original function? Well, I know that my y-intercept is positive 3, so 1, 2, 3, put our very first point. And I know that the slope, negative 2, can be written as negative 2 over 1. So we know that that's going to take us down 2 and to the right 1. And then down 2, so down 1, 2, to the right 1. And from there, we can go ahead and draw, well, I almost got it. We can draw our function. Now, what about the inverse function? Well, notice we change our f of x to y is equal to negative 2x plus 3. We then know that we're going to swap our x and our y. So now x is equal to negative 2y plus 3. And now let's go ahead and solve for y. So we know that we're going to subtract 3, of course that cancels. And now we have x minus 3 is equal to negative 2y. Of course, from here, we're going to divide everything by negative 2. Now recall, we can write this as such. Y is equal to x minus 3 all over negative 2. However, if I was going to graph this, I would actually like to separate this out. And I'll even change my y into my f inverse of x. So I can say f inverse of x is equal to, notice that this is a positive 1 divided by negative 2. So we have negative 1 over 2x plus, because a negative divided by negative is a positive, 3 over 2. Now one thing you should learn is that 3 over 2 is really 1.5. So if I were to graph my f inverse of x in white, I know that my 3 over 2 will take me up 1.5. So I'm right there halfway in between. And now I'm going to have to go, this negative goes at the top, down 1 and to the right 2. So I'll go down 1 and to the right 2. And if I go down 1 and to the right 2 again, I'll be on the x-axis. And you can see here that, oh, I'm sorry, this would actually be about halfway, and this should be halfway right there. Okay, and so you can see, well, this would look something like that. I kind of messed up my graph there. Okay, now more or less though, I want you to see something. Whenever you are graphing f of x and f inverse of x, you should always notice something. That the line y equals x, looks something like this. And notice how these two lines are reflecting across that line, and they both intersect on the line y equals x. Okay, so why in the world would a function and its inverse reflect over this seemingly arbitrary line y equals x? Well, it really has to do with the idea of a function. So remember this. Remember that a function switches our x and our y. I'm sorry, an inverse function switches our x and our y. So if I have the line y equals x and I switch the two, I have x equals y. Well, this is the one and only line where every single point, no matter where you switch it, it's still going to be the exact same. So whatever function you have, it has to reflect over that line. All right, let's go ahead and try one more example. Okay, here we have a very simple, easy function. F of x is equal to 2x plus 4. Well, let's just go ahead and graph that function first. And in fact, let me even graph it in a different color. Let's graph it in orange. So we know that our y-intercept is positive 4, and we know that our slope is 2 over 1. So we'll go up 2 and to the right 1. We could go up 2 and to the right 1 again, and we'll be about there, more or less. Now, if I draw my line, and let's pretend it's a straight line, it'll look something like that. So what would it look like to graph this function? What would it look like to graph the inverse? Well, we know we would change f of x into y, and we say that y is equal to 2x plus 4. I know that my next step is to swap my x and my y, and so x is equal to 2y plus 4, and here we're going to be solving for the letter y. So we'll subtract 4 from both sides, and we have x minus 4 is equal to 2y. Now remember, we'll divide everything by 2, and once that cancels out, I'm even going to take my y and I'll rewrite it as f inverse of x is equal to, and here we have our inverse function where this is really 1 divided by 2, so we have 1 over 2x minus, and 4 divided by 2 is 2. Okay, now what would this look like when we graph it? Our y-intercept is negative 2, so we'll go down 2 and put our very first point. And we're now going to go up 1 and to the right 2. So up 1 and to the right 2, and then I go up 1 and to the right 2, and you'll notice this line now looks like that. Okay, and the last thing I would say is these, even though it doesn't look like this right here, these are actually perfectly reflected across the line. Y is equal to x. So, boo me for being a bad drawer, but that is perfectly reflected across the line. Y equals x. Alright guys, good luck on this, and I will catch you in our next video.